Bonjour tout le monde. Alors aujourd'hui, nous avons une conférence inaugurale de M. Simon Thorpe, une figure de science d'envergure internationale, directeur de Recherche Émérite au CNRS et ancien directeur du CerCo à Toulouse. Il est franco-britannique. Il va nous parler de deux choses. D'abord, il va parler de ses travaux sur la simulation de réseaux de neurones avec plus de neurones que le cerveau humain, sur un Mac et avec une consommation énergétique très forte comme le cerveau humain. Et je crois que ce type de technologie permettrait à des gens partout dans le monde de faire de l'intelligence artificielle sans avoir besoin de passer par des sociétés big tech, surtout aux États-Unis d'Amérique. Le deuxième sujet, il va aborder un deuxième sujet, ce qu'il appelle lui-même dans ses écrits l'OUNET, une proposition d'un système d'échange parallèle à l'économie conventionnelle basée sur la dette avec des intérêts. Et ça va intéresser beaucoup de pays méditerranéens d'ailleurs, et des pays européens, surtout les pays européens, avec la guerre en Ukraine. C'est tout nouveau, comme ça marche très bien. Voilà, donc vous avez la parole, 20-24 minutes, et après je céderai la parole à notre ami, le professeur Michael Capasso, pour nous présenter en quelques minutes son ouvrage. Voilà, à vous la parole. Merci. Je vous demande de l'applaudir.
Merci beaucoup. On peut basculer sur ma présentation? Voilà, merci beaucoup. Et merci beaucoup pour l'invitation. Je suis vraiment très honoré de pouvoir parler devant des gens aussi prestigieux. Effectivement, on m'avait demandé qu'est-ce que je voulais traiter. J'avais proposé deux sujets en pensant que M. Azouzi allait choisir, mais il a dit non, il faut faire les deux. Donc j'ai pris le défi. Je vais parler en anglais quand même. So I think, like everybody yesterday, there are clearly threats from AI, particularly the concentration of control in a few tech companies, in a few billionaires, even trillionaires, and in basically a couple of countries, the US and China. At the same time, AI and robotics are removing paid jobs. So how will people survive? One option, obviously, is handouts. You could have universal basic income, but you'd have to do that globally for that to work, and I don't think anybody's seriously proposing that. And the other big problem is climate change, because these massive data centers are using a massive drain on both energy and water resources. So the two ideas that I want to propose are, firstly, Exabrain, which is a bio-inspired AI system that runs on 20 watts, the same power consumption as a human brain. It uses ultra-sparse spiking activity. Neurons send pulses, spikes in English. And the fact is that the number of neurons that actually fire may be a lot less than we think. I'm using symbolic coding at the neuron level, so neurons actually represent concepts. And I can have unlimited numbers of neurons and connections effectively. And as I'll show you, it runs on a Mac, and possibly, I haven't done this yet, but I think it will work on an iPhone. The second idea is IOUNet. It's a radical alternative to conventional economics, where people send IOUs, je vous dois in French, it's a term in English, instead of money. And the unit is not money at all, it's 1 minute of human time. It allows two things which I think are very interesting. One is periodic jubilees, where you cancel the entire debt in the system periodically. And the other is that it has no interest involved. So let's start with Exabrain. AI has a major energy problem. And if you wanted to simulate the human brain using the techniques of artificial intelligence, if you have 86 billion neurons, and roughly 7,000 synapses per neuron, and if you wanted to recalculate the state of the system 1,000 times a second, if you want to control speech and so on, you would need 600 petaflops. And there are only 4 supercomputers on the planet that could do it. 3 of them are in the States, one's in Germany, in Jülich, and that's what it looks like. It's a huge, huge computing resource. And all 4 of those computers use between 16 and 39 megawatts of power. The brain is nearly 1,000,000 times more power efficient. It only uses 20 watts. So the big question is, what's the brain's secret? How does it get away with 20 watts? Well, according to me, it's because of this ultra-sparse spiking activity. You can have lots of neurons, but if they're all very quiet, it doesn't cost energy. So basically, the idea is only a tiny percentage of the neurons fire. Now, to show the idea, I developed a thing called TerraBrain, which is a trillion neuron architecture that runs on a Mac. And I showed this for the first time at a conference in Heidelberg last year, and I'm going to show you what it looks like here. So this cube, this rotating cube, has roughly 17 billion neurons in it, of which only 64 are currently active. We can look at each of these neurons has 100 connections, and you can see I'm sort of flipping between neurons to show the 100 connections. And if I showed all the connections, all the targets of the 64 neurons, there are lots of red dots. Now, when I start the simulation, the 64 neurons that are currently active project to all their targets, and then we look to see which of the target neurons are the 64 most active ones, and they're the ones that fire on the next cycle. So when I turn the simulator on, you can see these neurons flashing away, and interestingly, this is the number of active neurons. I can increase the number up to 1,000, 8,000, 65,000, even 1,000,000, and this thing is still running perfectly well. Furthermore, this is the total number of neurons in the system, and it's currently more than the entire human neocortex. And I'm going to ramp this up to 1 trillion. It's like 12 times bigger than a human brain, and it doesn't make any difference. The code is running as fast because it doesn't matter how many neurons I've got, it's only the ones that are actually firing that matter. That's very different to the way things normally work. Okay, back to my presentation. So I didn't show you this, but that code runs on 20 watts, like the human brain. It also uses less than 1 gigabyte of RAM, which, my telephone's got 8 gigabytes, so I could run the entire code on a phone. What it's doing a lot of is reading all the lists of connections from an SSD, a solid-state disk. I've got 8 terabytes on this computer. That's a lot of connections. Now, as I pointed out in Heidelberg last year, it doesn't actually do anything. It's just a pretty demo. It just proves you can do lots of neurons on a Mac. And so more recently, I've been developing the next phase, which is called ExaBrain. And I'm using it to develop words and coding of words and concepts. So neurons are trained to code specific words, and we can link them together to make concepts. So here, I've got a sort of like an Excel sheet in which there are, here we've got lots of languages. There are actually 50 different languages in the simulation. And then we've got concepts down here, peace and water and bread and so on. So what the system does is it creates a new neuron for every word and every concept that's in the system. So for instance, P-A-I-N-N makes the word pain. And then we have other neurons that code the language French, and when another that codes the language, the concept bread, and then we create bidirectional connections between the words and the languages, and between the words and the concepts. And we do that for all the things in this Excel sheet. Okay, so I'm going to show you a demo of that. Whoops. So, I'm going to learn that concepts file for you. Start learning, done. A tenth of a second. It's learned all those different things. And now I can query by saying, let's say, pain. And what you'll see is that it's found 50 different words in different languages corresponding to pain in French, including bread, obviously, and khubz in Arabic. Where is it? There we go. But all the languages are in there. But of course, P-A-I-N is also pain in English, which means something completely different. And so that is mapped onto douleur somewhere. Where is it? But also elem in Arabic, for instance. So that's one illustration. Let me show you another one. I'm going to learn now some biographical data. So a lot more neurons here. We've got 263,000 neurons, lots of connections, and I'm now going to do another query where I'm going to say, let's say, look for composers, and it's got 2,000 composers in there. Let's now add in born 1756. There are 3 composers in the database born in 1756. And if I add in Salzburg, we're down to Mozart, okay? So this is looking through this, and it only took 25 milliseconds to retrieve that information. I've also got I've learned all the words in 50 different languages. It would take me 2 minutes to do it in front of you. I won't do that. Instead, I will just load up the data that's already been pre-learned, if you like. So these are all the 50 different languages that I've learnt. And if you want to see me do it, I'll do it for you. But it loads the entire thing in 280 milliseconds, and now I can do a query. Let's say, how many languages have pizza in it? And there you have 43 languages that have pizza in it. It takes milliseconds to find all those things. So that's given you an idea of what Exabrain does. The key is that when you're trying to retrieve information in Exabrain, you need very few neurons active. So for instance, if I activate the concept bread and the language pain, I get pain. The language French, I get pain. If I do the same thing for concept bread and Arabic, I get khubz. And I just showed you how to do three things: composer, born 1756, and Salzburg, and that would be like a 3D Excel sheet. But I could do it with 4 things or 10. It's the same thing. It finds things in this huge network of neurons extremely efficiently. Even with trillions of neurons, and all the data is actually stored on the SSD. So let's compare Exabrain with what everybody is using at the moment. Exabrain uses 20 watts, which is the same as a human brain. It learns incredibly fast. 250,000 neurons and a million connections in a second. The number of neurons is effectively unlimited, as is the number of connections. For instance, the Arabic language is linked to more than 1.4 million words, which is incredibly rich, I must say. And it takes milliseconds to retrieve the information, because only a very few neurons need to fire. Furthermore, the responses are totally explicable. I can tell you exactly why it said Mozart when I said composer born 1756 and Salzburg. And it runs on a Mac. Current AI systems, all the large language models, firstly, the learning is excruciatingly long. It takes gigawatt hours to train them. And you end up with a very dense network of neurons with literally trillions of floating point weights. And the problem is that all of these systems will answer questions, but every time you ask a question, essentially the entire system has to be put into action. And that's why it uses ridiculous amounts of energy. Furthermore, they hallucinate, as we know. They're black boxes. You can't understand where the answer came from. It's like there's this huge Excel sheet with trillions of things in it. And that means that it's difficult to control. You can't know what the system's going to do. And that makes it an existential risk to use these systems, because you can't turn it off if you don't want it to make some decision. Okay, that's Exabrain. On to IOUNet. This is an old idea that I'd been working on since actually I put it on my blog in 2014. Eureka, how to create unlimited amounts of money without banks, the OAM system. So here I had a little toy system with 10 different people sending IOUs to each other, but there's no actual money in the system. And indeed, the system starts with nothing in it. If I send an IOU to you for 20, I'm minus 20, you're plus 20. The system is still always at 0. And this means that, for instance, here you can get the builder owes the nurse 20, the nurse owes the hairdresser 20, the hairdresser owes the builder 20, and that makes a loop that you can cancel out. So for the next 12 years, I was basically trying to see if I could do the same thing, but with 10 million users rather than 10. And I was making some progress, but then it turned out that on the 9th of March, that's not very long ago, I realized that all of that looking for cycles and loops is a complete waste of time, because actually all you need to know is the net position of every user in the system. That's the only thing you have to care about. And we can have a Jubilee phase whenever you want, where all the people who are negative do things for all the people who are positive, and everything cancels out. And I'm using this thing as a measure, which is the minute of human effort. There's no money. The only thing that counts is human effort. Thanks to Claude's Anthropic's Claude, I managed to develop all this in the last few weeks. And there's a website that you can all go and have a look at if you want, called IOUNet. And I'm going to show you what the website looks like. So firstly, here's a little demo with just, sorry. I've got 5 people, Dan, Bob, Carol, Emily, and Alice, and they're sending each other IOUs for doing various things. And they each send 5 of them roughly, at the end of which Bob and Carol are both positive, Dan, Emily, and Alice are all negative. Now, what I can do now is a Jubilee where Dan, Emily, and Alice do things for Bob and Carol, and then you cancel everything out. So this is this Jubilee thing here, where when I do it, with 4 bits of work at the end, everything cancels out. So everybody is now back at 0. You can do that even if you've got 500 IOUs per person, and as you can see here, if I put auto Jubilee, it will do the Jubilee at the end. And this is taking 8 milliseconds with 5 people, 500 IOUs each. It's just a trivial computation. You can run this on your phone because it's not an app. It runs on your phone. That's with 5 people. Let's make it 500. Still works. So here we've got 500 people sending each other 500 IOUs. The total cooperative activity is 53 million minutes, and the whole thing runs on my laptop. So that's one demo. Here's another one. Another little demo here where I've got 5,000 people all sending each other IOUs. So the red ones are negative, the blue ones are positive. And this is the total number of IOUs exchanged here and the amount of cooperation. And every now and then I do that Jubilee thing. So all the people who are negative have to do something for the people who are positive. Everything cancels out. And you can just leave this system running. You can have cooperation, and there's no money changes hands. It's just all done with IOUs. And then finally, let's have a look at this other planetary simulation, which is actually running on I've got a Mac Studio at home, and it's been running for 41 days with 10 billion users simulated. Why 10 billion? Well, that's more than the number of people on the planet, but I'm counting in the idea that every household and every business and every charity and every school and every government could also have an IOUNet account. And you can see here the distribution of negative and positive values, but here's the fun thing. Every 2 hours, I do a Jubilee. The Jubilee says that all the negative people do things for the positive people, and everything cancels out. So you can see this. If you go to the site every 2 hours, you'll see the entire debt thing just collapsing to zero because of the Jubilee. Right, back to the thing. So what's the relation between this and AI? Well, the fact is that as far as I'm concerned, anything that's 100% AI does not count because there is no human activity. And that means that humans cannot be replaced by AI. They can be augmented, but they can't be replaced. And indeed, a human with AI support can do lots of useful things. And I'd like to suggest that what you've seen today is an illustration of this, because TerraBrain was done in 3 weeks with me, with help from Anthropic's Claude. Exabrain learning took me 2 weeks. IOUNet learning, I've just showed, that's basically took 2 to 3 weeks. So it's one person with a lot of help from an AI system. But the AI system is not earning anything here. And Claude's perfectly agreement with this. He says, yeah, no, or he or she hasn't earned anything. It's human cooperation which is being rewarded. The AI earns nothing. The IOUNet also is really good for economic analysis, because I didn't show you this, but in the big global simulation, I'm tracking where all the activity is going on. Geographic location, but also types of activity. Is it childcare or looking after elderly people or driving people around? What sort of entities are doing it? Is it individuals or businesses or governments or charities? And also the demographics, what age are the people and so on. All of that is for free. And it's a vast improvement on what everybody else is doing, which is gross domestic product, which only measures financial transactions. What about all the things that people do for free when they're looking after their elderly relatives and the rest of it? That stuff is not counted. And so everything that people do spontaneously gets neglected. So a couple of neglected ideas from history. One is periodic debt cancellation. This is a really old idea. The Babylonians did this 4,000 years ago. Every 7 years, all the clay tablets were smashed by the king. Debt was eliminated. It's in the Bible, Leviticus 25. The other thing is usury, charging interest. That was forbidden in the Hebrew Bible. It's Christian doctrine for 1,500 years. Dante's Inferno put all the usurers in the 7th circle of hell, and of course Islam has maintained a prohibition on riba for 14 centuries. The trouble is that modern finance has abandoned both of these things. We have compound interest and unbounded debt, which means that today global debt is at $348 trillion, and it's killing everybody. Rich countries are crushed by interest. The UK is spending currently 100 billion a year on interest payments. France will be paying 100 billion euros a year in 2030, and 3.4 billion people live in countries where interest payments exceed all spending on health and education. And the net result of that is that the 1% at the top get all the money because the interest goes up. So IOUNet quietly restores both jubilees and interest-free economies. So these are not new ideas, they're just ones that have been overwritten by the way the world works today. So IOUNet's key messages: human cooperation is possible with no money. Individuals can help each other and live fulfilling lives that way. It's the end of what David Graeber called bullshit jobs. He pointed out that if you ask people whether what they do to earn a living has any value, 50% of people say no. They do it because it pays the rent, but they don't think it's important. Okay. Could it replace the current financial system? Perhaps, but I don't think it's necessary. Just let me point out, it's all free. I'm giving this away. You can just join IOUNet if you want today. And I put these things in 12 different languages. Last slide, Exabrain, as I say, I've given you the details. IOUNet. For me, Exabrain is the antidote to big tech domination because it makes AI democratic. People can do it themselves. Secondly, IOUNet is the antidote to big finance domination. It's democratic economics. And final point, both were developed with a lot of AI, but humanity is at the center.
Thank you very much.
There you go.
Merci beaucoup.